Welcome, class. So today I will be teaching you guys how to graph vertical and horizontal hyperbolas. So here is the standard equation of a hyperbola, which is x minus h squared over a squared minus y minus k squared over b squared. So the example I'm using is x squared over 9 minus y squared over 4. So first of all, you have to find the a and the b, which I found the a from the square root of 9, which would equal 3, and I found the b from the square root of 4, which would equal 2. So now I am preparing my graph for the horizontal hyperbola. So since this graph is going to be horizontal, I have to look at the positive side, which would be x. So then I would start with the 9, which the a would be equal to 3. And then I start to graph the y side, which would be the b, which would equal 2. So then I start to draw my box, which would help me graph my asymptotes. And then I start to draw my dotted lines, which would also help me keep the hyperbola curve in place. Okay, now, so since it's horizontal, I graph the left side of the x-axis, and I graph the other side of the x-axis. So after you get both curves, you have to find the foci, which the equation would be c squared equals a squared plus b squared. So then I plug in my values and I try to determine what c would equal. So it would turn out to be c squared equals 9 plus 4, which c squared would equals 13, and then c would end up equaling square root of 13, which would then be approximately 3.4. Or actually 3.6, scratch that, 3.6. So then I put my foci up on the graph, and that's how you graph a horizontal hyperbola. So next example would be a vertical asymptote with an axis not at 0, 0. So then the standard equation of a hyperbola I would change to y minus k squared over a squared minus x minus h squared over b squared. So then the center would actually be h, comma, k. So then I go through the same steps again to find the foci, plug everything back in just to determine the c, which would then approximately equal 6.4. So here I am preparing the graph. So then, since it's going to be a vertical hyperbola with an axis not at 0, I would start trying to graph the center, which would equal 1, comma 2. And then from there, I add up the a and the b. So then the vertical axes would be a plus 5, and then the horizontal axes would be a plus 4. So then I start to draw my box to prepare for the asymptotes. And then I start to draw my dotted lines to help keep the hyperbola in the right place. And then I draw my hyperbola curve from the vertical side of the top of the y-axis and also on the bottom side. So the next step would be to graph the foci, which is the same thing. I plugged in everything and then the C approximately became equal to 6.4. So now, since it's vertical, I graph it on where the hyperbola opens to the vertical side, which is the top of the y-axis. So then I grab a 6.4 up there and a 6.4 below. And there you go. I have now completed a graph, a vertical hyperbola with the axis not at 0, 0. Thank you.
How to graph an ellipse. The standard equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. That tells us that the center is at 0, 0. Our problem is 4x squared plus y squared equals 144. The first thing we're going to do is divide 144 on both sides. That gives us x squared over 36 plus y squared over 144. According to the standard equation, we take the square root of both numbers, and that tells us how many units we will be going on the x-axis and on the y-axis. So that would become 6 squared, and this will become 12 squared. Because the larger number is under the y-axis, that's going to be the major axis. So the major axis is going to be vertical. So we're going to travel 12 units up and 6 units to the right and left. So we know the center is at the origin because we don't have a vertex. We don't have a center. So we go up 12 and we go down 12. And we go to the right 6 and to the left 6. And that gives us our vertices and co-vertices for the ellipse. Because A equals 12, the vertices will be 0, 12, and 0, negative 12. And because B equals 6, the endpoints of the minor axis, or co-vertices, will be 6, 0, and negative 6, 0.